If you have hired on Upwork, please raise your hands. All right. If you are working on improving your current data and machine learning infrastructure, please raise your hand. That sounds good. As you might know, Upwork is this largest online labor marketplace where large companies like Facebook, Google, Microsoft, and also individual clients come to hire contractors. And we have tens of millions of contractors on Upwork who want to find work. I run search and recommendations, and also I run the data science infrastructure team at Upwork. I joined only almost a year ago. And today I would like to tell my story how I built my team using our Upwork platform, and also how we rebuild and improve our current data and machine learning platform. So my mission at Upwork really is to grow and establish this world-class data science team. And as you know, talents in the Bay Area are hard to come by. Recruiting is really competitive. We have to compete with all these major companies that just won't stop hiring, and then we have this new wave of AI startups. And as you shall see, we actually have a very positive and very compelling mission, and we have really unique data science opportunities. And with this, I think we have a very good motivation, but we don't scale as quickly as we like to. The good news is we have this Upwork platform, and we drink our own champagne. Within only a few months, I was able to bring in a few key data science hires, like ex-Apple manager who decided to move to Panama, top 10 Keiku grandmaster, and also some of my former PhD students who are now working in Germany and who have joined my team. So we were able to bring in long-term hires, but then also there are a lot of these like 0 to 1 projects where uncertainty is high. The outcomes is not really clear. Short-term projects where maybe capacity reduction would make sense when we're done with them. And for this kind of short-term project needs, we were able to bring in short-term hires and consultants who can help us with current projects. So within only a few months, we were able to hire more than 10 people and almost doubled our capacity to address this increasing needs that we have for data science expertise. And based on this personal experience, I can really speak with confidence that hiring on Upwork is a very successful strategy in order to grow your team, as well as to address short-term project needs. And this is because right now I can say that both I and my team are better off because we are able to improve along 3 major dimensions: quality, cost, respectively earnings, and agility. And this is because I was able to bring in the highest talents using Upwork, and my team members would not be able to work on cutting-edge projects if it wasn't for Upwork. They would have to relocate, move to the Bay Area, or make very difficult trade-offs. And I was able to hire my team members at a rate that is competitive. And for them, it's also compelling because given their location from where they work and the flexibility they have in managing their work hours, they are very happy with the compensation. And they are happy with a level of compensation that would be lower than the rate that they might be able to get if they move to the Bay Area. And I think the most important thing is we are able to address short-term project needs. We don't have to make long-term commitments. And the consultants and contractors that are working with us are also happy because they don't have to make these long-term commitments. They want to work only when they want work. So we think that this positive experience applies to all clients who want to hire and all contractors who want to work. We think that if we do our job well, we can really significantly improve the welfare for contractors and clients on our platform. And the main mission of our data science team really is to using data science methods in order to optimize the labor marketplace exchange in order to drive significant improvements in welfare. The illustration on the right-hand side really captured the gist of our mission, as you can see here, based on my personal experience. We like to improve welfare for both our clients and our contractors by improving quality, cost, respectively earnings, and agility. Our clients can improve welfare by getting more job done at higher quality and lower cost, and our contractors can improve their welfare by getting better jobs, higher compensation, and working fewer and more flexible hours. So our mission is really to move from this status quo distribution of wealth right now for clients and freelancers to a more Pareto efficient distribution on this Pareto efficient curve. We want to improve the welfare for both our clients and freelancers. The core challenges that we find with this mission is, first, we need to ensure adequate supply and demand. Then we need to reduce costs and efforts for our clients to find contractors and for our contractors to find jobs. We refer to this as matching costs. And also we need to reduce costs and efforts for them to conduct the business, which we refer to as transaction costs. Especially when you look at the matching problem, you would think that we can apply state-of-the-art in search and recommendation and help contractors and clients to find better matches. And this is true to a partial extent, but I think the unique challenge that we're facing on Upwork here is we have a multi-sided matching problem. The multiple sides that are involved include clients, contractors, but also the marketplace perspective. As an example, for instance, for our client A, we want to find contractor B who is right for the job. We want to make sure that B also wants A's job. And now A might have very high buying power, and B, the contractor, is fairly new to the platform, so she might be willing to take a much lower rate. If we were to take this rate as the standard, let's say we use this rate as minimum rate, or we use it as a rate to help other freelancers to make bids, rate commendation, then in this way, we would make a lot of the freelancers unhappy because they have to compete at this very low rate. But it's not only about A and B, it's not only about the clients and the freelancers, A and B in this case, but it's about the overall marketplace health and growth. In order to ensure that, in this example, what we need to do is actually we need to identify what we call a Pareto efficient market clearing rate that makes all the clients who are similar to A, clients that want to get a job done similar to A, be happy to accept that rate. And we also need to make all the freelancers that are similar to B be willing to take that rate and be happy with that rate. So to sum up, the core data science challenge that we face at Upwork is what we call multi-sided matching, and we need to take multiple perspectives into account. And the good news is we have a great team to figure out the science, and we have plenty of data. So we have large quantity of data. And more interestingly, I think the data that we have at Upwork is contextually very rich. So if you compare Upwork with other job platforms like Monster, for instance, they know what are the jobs that are out there and what are the folks that apply for the jobs. Our funnel is actually much deeper than that. So in addition to job application, we actually also own the data about job execution. We know how the contractors do in interviews. We know the messages that clients and contractors exchange through our marketplace. And we also know whether and how the job was done. So we have a closed loop data set from job application to job execution. All right, so how do we go about solving this multi-sided matching problem? How do we build our data science products? We learn from best practices in software engineering and customize it to the unique challenges that we find in building and engineering data science products. So we adopt an agile data science product engineering workflow, which starts with data analytics. So we have data-driven thoughts experiments based on which we establish hypotheses. And the goal is always to quickly build an MVP, design a scalable and lightweight experiment that we can use to get some quick reads. We feed the data back to analytics. quantify the improvements, and validate the hypothesis that we have established in the first place. Now, so let's suppose that the goal here is to build a job recommendation model, right? We want to recommend relevant jobs to our contractors. How do we do that? And what are the challenges that startups, sizable startups like Upwork are facing? And I think if we go through this workflow from data analytics to building the model to putting the model in production, to start with in data analytics, the challenges that we find is that through the proliferation of tools for data logging, processing, and so on, even for metric computation, you might have different teams owning different ways of computing the metrics. So there's no single source of truth that we can use to evaluate the current model. We find that actually understanding whether the model is currently working well is not such a trivial task. And quantify improvements continuously, of course, require the tool chain, the workflow that helps you to quickly get these metrics in a continuous fashion. When it comes to building the model, I think the challenges that I like to point out here is, if you look at the data that would be required in order to build this job recommendation model, right? So on the one hand, you need client data, you need to know the clients and the job openings that they have, and we need to know also the contractors and the applications that they send out. In addition to that, we also want to exploit browsing behavior, right? So we want to collect also UI events that capture all the interactions between freelancers in our system. And based on that, we can use it, for instance, to infer the short-term interest, right? Contextually, what is the browsing, the session-based interest that we can learn here. And in building the models, we find that in order to get client and freelancer-related information, which comes in what we call business objects, that's really straightforward, right? It comes from production system, you can set up the tool chain needed in order to get the data. But the UI events come at large volume. And again, because as the company grows, you have a lot of these product teams that own different pieces. They have different data dictionary, different standards. Making sense of these UI events and use them effectively to train the model, to build labels for the model is a task that requires lots of efforts in data cleansing and data processing. Moving on, I suppose that a lot of you has gone through this experience where we use a traditional data warehouse, and this data warehouse solution is employed for both data analytics, and it's also used by the data scientists to run data processing jobs, right? We found that this traditional solution doesn't scale well. Our data scientists often run into performance issues, workload limitations, and that seriously limit their ability to fully untap the value potential of our data. And once you have built many models, right, chances are really high that you can reuse code, reuse features that have been shared, but that means that you actually also have to extend the data governance practice that you have in your company from data to features, right? You need to have well-documented schemas for the features, and you also need to have the libraries and the workflow support in order to compute the features for our data scientists. Once the machine learning pipeline is built, which is done using batch data, and when we ship it in production, we find that often it doesn't meet expectation. And the reason is that, again, due to the complexity, the batch environment that we use in order to compute the data and train the model, there might be differences between the batch environment and the live data environment that we use to score the model. And with these differences, we find that often there are these batch and live data mismatches. And having an effective tool chain in order to identify these mismatches really help in reducing the needs for debugging and understanding differences between live model in production versus model trained by our data scientists. And I like maybe to skip to the most important thing that we have observed is that there's always a natural tension between flexibility and standardization. As a data scientist, of course, I want to be flexible. I want to be able to leverage the most advanced bleeding edge machine learning library in order to build a very complex and successful model, but this would lead to a lot of ad hoc pipelines, and this would result in much greater engineering efforts needed in order to put the pipeline in production. Now, as a machine learning engineer, I'm responsible to put this pipeline in production, so my attention and my focus rather is to minimize the gap between the pipeline that I put in production versus the pipeline that is trained by the data scientists. Without lots of additional coding, I would like to be able to put this pipeline through the CI/CD workflow, test the pipeline, and make sure that the pipeline deployed in production produce the same results as expected by our data scientists. So it boils down to find the right trade-off between flexibility and standardization, because when you think of having a standardized model serving environment, having too many ad hoc pipelines and managing all these pipelines is also very, very intensive in terms of engineering workload. So what we have done is we have almost completely rebuilt our data and machine learning pipeline. We have replaced major components, and this is the overview that you can see. Maybe just to point out a few key highlights in order to support high throughput, live data processing to support real-time use cases. We make use of Spark, structured streaming in particular, and Kinesis for scaling our batch computation and to avoid the workload limitations that I mentioned before. We use Spark mainly for the batch environment. To settle on a reasonable trade-off between flexibility and standardization, we use a combination of Spark MLlib for building our models and TensorFlow. The CI/CD workflow support is very crucial for us, and we have customized it so that it works for our data scientists. And one key difference is that model management as well as the management of experiments become a major part of the CI/CD workflow. And with this workflow, we can test the trained machine learning pipeline as built by our data scientists in isolation, but also we can test this pipeline as it is shipped into our production environment. So now I'd like to maybe capture a bit more details and go through the batch environment, the live data pipeline, and our CI/CD workflow. As you can see here, the batch environment is used mainly to process data, compute features, and to train models, and also to run the model that have been trained to compute prediction results that we can use to materialize and make the pre-computed results available to external consumers. At the core of this, we use Airflow, which is our coordination engine in order to orchestrate and schedule all the different kinds of batch processing jobs. So first, typically what is part of this workflow is to get the data from our original sources, which in this case are either production databases or data that we have in our data warehouse. We use mbug in order to continuously ingest the data from the data sources into our batch environment. And the batch environment basically can be conceived as two components. One is the storage layer, and the other is the processing layer. The storage layer is essentially a data lake that is implemented using S3. And for processing, as mentioned, we bet strongly on Spark. So we use Spark for ETL, we use Spark for feature computation, and we also use Spark in order to build the model as well as running the model in order to produce results. For managing the data, we use both managed and unmanaged tables. So for the kind of data that is frequently used by our data scientists, we have our Databricks specific S3 bucket, and with this managed table strategy, our data scientists can leverage the inbuilt Hive metastore in order to browse the data, view databases, tables, and so on, And we can also leverage the SQL optimization that comes with Databricks in order to run the jobs faster. And once we use this batch processing environment in order to pre-compute results in batch, we can make them available to consumers. In our scenario, we have basically two types of consumers. First, for the search and recommendation use cases, we have helpers, basically jobs that pick up data from S3 and write the data into the search engine indexes. And then we also have microservices that make use of the pre-computed prediction results via a JDBC and ODBC endpoint that we provided. So this is a slightly more detailed description of this workflow. And suppose maybe the workflow that we would like to support here is this job recommendation model, right? We have trained the job recommendation model, and we want to use it in order to provide job recommendations, and we run this model scoring in batches. The first step is to use Airflow and configure everything that we need in order to run this workflow. And I think the two major components is, on the one hand, the data. So what are the input sources? What are the tables on S3 that we need? And what are the specific Spark jobs that we want to run with this workflow? And as you know, with Airflow, we can use essentially Python code in order to capture this fairly complex workflow that might have the shape of a directed acyclic graph. And in this way, we can flexibly put together a very complex workflow in order to support this scenario. So once we have done the configuration, Airflow has all the metadata needed and all the artifacts that are required in order to trigger this workflow. And the first step is, as mentioned, we would use Embark in order to load the data, write the data into the loading zone. Then we run with Spark some ETL, standard ETL tasks, including data normalization and so on and so forth. We write the outputs of this ETL job into the release zone. And now as the data is cleansed, is processed, we are ready to run the jobs that are required in order to compute the model predictions. And as you know, the machine learning pipeline required in order to obtain model predictions consists of the feature computation part and the actual model scoring part. And these are the two steps that we also run using Databricks notebooks. And the outputs are written into Spark SQL, our endpoint, and our data lake, which is the release zone that we use here. Moving on, just to share with you some experience in building the live data pipeline, I think it's important to point out that the kind of processing tasks that we execute in this live data environment is very similar to what we have seen in the batch environment, right? So essentially, ETL, feature computation, model scoring, all these jobs are the same. In fact, we are able to reuse most of the code that we use for the batch environment and run this code also in the live data environment. The difference here is with this live data environment, we want actually to provide real-time predictions, right? We run these jobs over streams instead of data stored in S3, and we can provide real-time predictions. Why is it important? Going back to our example of this job recommendation model, right? If you run the job recommendation in batches, you wouldn't be able to take the session-based information into account. So if you want to update the recommendations as the user browse all these applications and you want to take this short-term interest into account, you actually need to provide real-time updates for these recommendations. And this is the use case that we can support with this live data pipeline. The core components of this live data pipeline, and then I would say is Kinesis on the one hand and Spark structured streaming on the other hand, because all the jobs that we used before in the batch environment, ETL, feature compute, and model scoring, essentially the same logic, the same Spark notebooks, but now we run these notebooks over structured streams instead of data stored in S3. Once the model scoring has been successfully run, we store the outputs into DynamoDB, and model consumers pick the data up from the DynamoDB in order to serve the recommendations. I think one interesting challenge here is that in order to support computing recommendations in this case, actually what we need is not only recent data that we pick up from all these microservices that goes to our Kinesis and structured streaming pipeline. We also need batch data, because for recommendations, not only we care about the short-term interest, but also long-term preferences, right? So actually, we also have to go to the data lake and retrieve data, join data with live data in order to collect all the data we need for future computation. And this is illustrated a little bit more clearly with this workflow, where you see here that we have a relay that listens to all these live data updates and data creation events. Based on these events, it picks up the data from the microservices, then it goes to Kinesis, then we run these various structured streaming jobs. The interesting point here is, in order to combine live data with batch data, what we can do is stream to batch join, right? And we found that with stream to batch join, actually, with our infrastructure and the way all these microservices are set up, we have a very large number of model consumers. And also, stream to batch join, when the amount of batch data is very large, performance is a serious issue. So we spend lots of engineering efforts in optimizing this kind of stream to batch join. And with our newest pilot, which is Databricks Delta, we found that this might be a promising solution in order to reduce engineering efforts and address some of the performance bottlenecks that we have. And finally, let me share with you a few insights that we have learned from building the CI/CD workflow. I think one important key difference compared to a traditional CI/CD workflow that you have in software engineering is that for machine learning, you have various kind of artifacts, right? So in addition to the code, which is our machine learning pipeline here, we also have test data that we want to use in order to compute the metrics. And in our case, remember when I mentioned that we have live and batch data mismatches? I think one important goal for us also was to identify these mismatches and to see whether the train pipeline in the batch environment actually behave similar to the pipeline deployed in production on live data. And this is why we also have continuous regression notebooks that becomes artifacts of this CI/CD workflow. So we build out different libraries in order to manage these artifacts, to execute the pipeline, and to run the pipeline. In order to execute the pipeline, it is important to know that in order to support this flexibility, right? So in there, not only we have Spark MLlib, we also have TensorFlow. And in fact, in our context, we also run learning to rank using Solr, which is yet another execution context. And then we want to execute the pipeline in batch mode or over live data. So in order to support all these different scenarios, what we have is an abstract execution environment. And depending on what is the actual use case, what is the actual deployment scenario for our machine learning pipeline, we would pick the right one in order to execute the model. And in the end, it looks like this, right? Where we have, for CI/CD workflow, we have 3 phases. The first is the pipeline development. The second is the pipeline testing. And the third is the continuous setting. In the development phase, we have the data scientists developing the notebooks. They can run the experiments, store the experimental results. And then when they are happy, they would commit the code to Bitbucket in our case. Then with Jenkins, we built this pipeline, and now we're ready to test this pipeline. The pipeline is tested on the one hand in isolation, and on the other hand in the regression setting, where we use the actual components that we would use also in the production environment, and we use the live data. And the live data comes through this Airflow-based orchestration where we run the regression notebooks in order to provide this live data for testing. Thanks.